Okay.
For the moles of NH3, 5 milliliters.
Yeah.
Is that the?
That's for you. Let me look at the table here. For you.
Where is that?
Yeah, it's
Is that the 6?
that's the 6 here for you guys. Okay, that's the 6 milliliter there, and the volume, and 5 here, the molarity of the ammonium hydroxide. NH4, that's the source of the ammonia. You know, I'm writing it in H3, but I already explained this one time before when we were doing the Schoettler principle and adding ammonia or adding HCl. You see, actually, what we are using ammonium hydroxide, NH4OH. That's the source of the ammonia. But ammonium hydroxide, as I told you before, simply you take ammonia, NH3 plus H2O, bubble it in water, and give you NH4OH. So this is NH4OH is the source of the ammonia. Okay. So, up to this point, guys should be able to go and use that numbers and generate this data I did in the table. Right? Anybody has a problem with this? Everything is clear up to now? Okay. The second part of the calculation, and please, you have to show your calculation. They want you to find pH of 50 milliliter of 1 plus 1 milliliter of 0.6 molar sodium hydroxide. Do you understand that? That first part, how to do that? Okay. Show your calculation, pH. Now we're going to apply what we learned in our. Okay, we need to find pH of I have to take this number. 50 milliliter of water, 50.0 milliliter of water plus 1.00 milliliter of 0.6 molar NaOH. You know this stuff very well, right? You have a solution here. You got 50 milliliter of water, water here, H2O, plus 1 milliliter of 0.6 molar sodium hydroxide. So you have to apply this dilution C1 V1 equals C2 V2 to find what's the molarity once this solution actually once this 1 milliliter of 0.6 molar diluted to 51 milliliter, what will be the molarity, right? Right? What it is here, simply, that's what we would have done in the lab if we were doing the thing on the lab. You know, we would have 5.00 milliliter of water. We added 1.00 milliliter of NaOH, which is 0.6 molar. We mix it and we measure the pH, but we want to do it, we do the calculation now, how to calculate that. So just you apply that, this is, you find your molarity, or, you know, C1 V1 equals C2 V2, because it's a dilution here, right? So you have 1.00 milliliter times 0.6 molar equal the 50 plus 1, 51.0 milliliter times C2, right? And you find the molarity, so you will find actually C2 here equal C2 equal is, I got the number for me, 0.012, because we have somewhere we have only we'll take 0.012 here. 0.012 more. That's the concentration now of that solution. What we'll find, how to find the pH. What you do for this is sodium hydroxide. So what you have actually, here it is. Excuse me. NaOH plus H2O will go to Na plus OH minus. So we have here 0.012 molar. Because this is a strong base, when it will ionize, give you completely 0.012 here moles and 0.012 here moles. How to find the pH? We need to find the pOH and then subtract from 14. So because this is sodium hydroxide solution, so you find pOH equal minus log OH minus concentration equal minus log 0.012, and it comes to 1.92 to 1.92, and your pH, you know that pH plus pOH equal 14 for any aqueous system. Okay, so from that, and then you subtract, and your pH equal 12.1, you know, you can take it to 12.1. The main thing is the principle. I want you to understand the basis, how you move in this, how you do this calculation. Okay?
So is that number the same for everyone?
For this particular one, yes.
Okay.
For this particular one, because we all use 50 milliliter of water, we all add 1 milliliter of, the only difference is your buffers. Those buffers you prepare, you know, and I really don't worry about it that much. You know, they are, I don't expect to see your copy from each other. So as long as you, but this is the same for everybody. Now, now the second question is pH of 50 milliliter of water plus 1 milliliter of 0.6 molar HCl. Now, instead of adding here sodium hydroxide, let's see, we add 0.60 molar HCl. Now, the same thing, C1V1 equals C2V2, and your acetic acid here will be, the molarity of your solution here will be same thing, because will be 0.012 molar HCl, right? Because the same volume, same concentration, everything is the same. Now, the only difference now, look here, you're going to do the calculation for pH. So you have HCl here plus water goes to hydronium ion plus chloride ion. And this is 0.012 molar to give you 0.12012. Okay, so this is an acid, so we go straight directly. So pH equal minus log hydronium ion concentration equal minus log 0.012 and equal the number which we have it somewhere here, 1.92. So that will be 1.92. Actually, this value, you can use them straight for your report. Right? Okay, up to now. Do you see those numbers there, or I need to write them bigger, or what? Or is it okay? Because I cannot see them very well. Maybe I need to check my glasses. Or maybe that's why I was sitting in the back. Okay. Up to here, we okay here? We can clean up this because I need to, I'm gonna leave this side here because I'm gonna use those numbers. Okay? This is I'm gonna clean this side. Okay. So we determine, or we found out the pH of an aqueous solution of sodium hydroxide, aqueous solution of the HCl. Now things getting a little bit more, require more thinking. Now we need to find the pH of the buffer solution. Now the question is here, pH of your acetate buffer. They want you to find what's the pH of that solution in your 250 milliliter flask based on the information you got. Now we need to apply here, write this equation here. Very important equation, pH, pKa plus log base over acid, okay? Conjugate base over acid, okay? And here's for this acetic acid, for our buffer acetate would be CH3 here, O minus over acetic acid. This is the pKa of a weak acid, which is acetic acid. We know that. We did that in our Ka for acetic acid. And that value, which is 1.8 times 10 to the power minus 5, somewhere there. I know the value for the pKa, which is 4.74. So here, this is, you can use this value. So it will be 4.74 plus log. Where I'm gonna get the acetate here, the acetate molarity from? I go back here. Molarity of sodium acetate, 0.0968. This would be 0.0968.